Across some of the most challenging landscapes on Earth, humanity has always been driven to attempt the impossible. It is a story of ambition, of necessity, and of an unyielding desire to connect. Here, on a scale that defies imagination, that story is being written in steel and concrete. We see bridges that stretch above the clouds, their immense towers piercing the mist like needles. They connect mountains that were once separated by days of treacherous travel. Now the journey is measured in mere minutes. This is a world where human ingenuity is not just a concept, but a physical force, reshaping the very ground beneath our feet and redefining what is considered possible. We witness trains that glide across vast, frozen landscapes. Their sleek forms a stark contrast to the raw, untamed wilderness they traverse. These are not just machines, they are lifelines, carrying people and goods through environments that would otherwise be completely impassable for much of the year. In the distance, megacities rise from the plains at dawn, their skylines growing and shifting with astonishing speed. Each new structure, each new road is a testament to a relentless drive forward. The air is filled with the sounds of this transformation. The low hum of distant engines, the sharp clang of steel on steel, and the ever-present whisper of wind against colossal structures. This is a land of immense scale and profound contrasts. It is where ancient traditions meet futuristic ambitions. The sheer scope of these projects can be difficult to comprehend. They are not merely additions to the landscape, they are fundamental alterations of it. Highways are carved into sheer cliff faces, dams hold back the power of mighty rivers, and tunnels burrow deep beneath impenetrable mountain ranges. Each project represents a monumental undertaking involving thousands of people, years of planning, and groundbreaking technological innovation. The goal is simple, yet incredibly complex, to overcome the natural barriers that have defined life here for millennia. These engineering marvels are more than just impressive feats of construction. They represent a fundamental shift in the relationship between people and their environment. They are solutions born from necessity, answers to the immense challenges posed by a vast and often unforgiving geography. From the highest plateaus to the deepest gorges, a new map is being drawn, one not of natural obstacles, but of human-made connections. This is the story of how a nation is engineering its way into the future, pushing beyond limits that once seemed absolute and permanent, building pathways where none existed before, To understand the magnitude of this endeavor, one must first understand the land itself. China's geography is a tapestry of extremes, a continent-sized nation defined by formidable natural barriers. A map reveals a landscape that has, for centuries, dictated the limits of human movement, trade, and settlement. To the west, the colossal Himalayas, the Tibetan Plateau rise to form the roof of the world, thin air and frozen earth. To the north, vast deserts like the Gobi and the Taklamakan stretch for thousands of kilometers, shifting sands that threaten permanence. These are not the only challenges. Great rivers, including the Yangtze and the Yellow River, carve deep paths through the country. While they have been cradles of civilization, their immense power also brings the risk of catastrophic floods, capable of displacing millions and reshaping the landscape in an instant. Furthermore, much of the country lies within active seismic zones, where the ground is unstable and earthquakes are a constant reality. This complex and often hostile terrain has historically isolated communities, creating regions separated by impassable mountains, raging rivers, and desolate wastelands. For generations, this geography was an accepted fact of life. Journeys that would take hours in other parts of the world could take weeks or even months here. Trade routes were perilous and unreliable, and the economic development of entire regions was stunted by their profound isolation. The sheer difficulty of traversing the land meant communities remained disconnected, their potential for growth and collaboration severely limited. In this context, engineering is not a luxury or a matter of convenience. It is a fundamental tool for survival, for unity, and for connection. It is the primary means by which a scattered population can be woven into a cohesive whole. The story of China's modern engineering is therefore a direct response to these age-old challenges. It is a narrative about overcoming geography, not just for the sake of progress, but for the sake of national cohesion. Each tunnel bored through a mountain, each bridge spanning a gorge, and each railway laid across a permafrost-laden plateau is a deliberate act of defiance against the limitations imposed by nature. It is an attempt to create a world where distance is no longer an insurmountable barrier, and where the nation's most remote corners can finally be brought into the fold, transforming isolation into integration. For centuries, the vast Tibetan Plateau remained one of the most isolated places on Earth, a realm of soaring peaks, profound spiritual significance. It was cut off from the rest of the world by a near impenetrable barrier of mountains, extreme altitude. Reaching this roof of the world was a quest reserved for the most determined explorers, pilgrims. A journey that took months of arduous travel over treacherous terrain. The idea of a modern, efficient transport link to this remote land was long considered a fantasy, an engineering dream bordering on the impossible. The sheer scale of geographical and environmental obstacles seemed to place it beyond conventional construction. The dream, however, persisted. The strategic importance of connecting the plateau to the rest of China. The economic importance, driving decades of planning and research. The primary challenge was elevation. Any railway line would have to climb to altitudes exceeding 5,000 meters, or over 16,000 feet, traversing hundreds of kilometers where the air is thin and the ground is permanently frozen. This was not just building higher than ever before. It was confrontation with environmental conditions that threatened every aspect of the project, threatening the stability of the tracks, threatening the health of workers and passengers. The ambition was to create a steel artery to pump life and commerce into an isolated region. Such a railway would be more than a transport route. It would have to be an all-weather lifeline, capable of operating through the harshest winters and the most volatile conditions. It would require engineers to write an entirely new rulebook for high-altitude construction. They would have to conquer problems never solved at this scale: how to build on unstable, frozen soil, how to operate machinery in extreme cold, how to protect human life in a low-oxygen environment. This quest was as much a scientific expedition as a construction project. It demanded unprecedented innovation and a willingness to, push the boundaries of known engineering. The result, the Qinghai-Tibet Railway, is a testament to that ambition. It stands as a symbol of human perseverance against overwhelming forces of nature. The story of its creation is a modern epic of ingenuity. Planned, engineered, ultimately realized, forever changing the destiny of this remote, once unreachable corner of the world. For the first time, these regions became reachable. For millennia, deep gorges, wide rivers have acted as profound dividers of the land. They are chasms in the earth, natural moats that dictate the flow of life-commerce communication. To cross them required long, arduous detours or reliance on small, often precarious ferries. In a country as vast and geographically complex as China, these natural barriers have long been a fundamental obstacle to national unity, economic development. The solution, born of necessity and ambition, has been to leap over them. This has given rise to an unprecedented era of bridge building, transforming impassable canyons into mere moments on a journey, creating pathways in the sky where none existed. The modern megabridge is a masterpiece of both art and science. Two primary designs have come to dominate these colossal structures. Suspension bridge, cable-stayed bridge. A suspension bridge, like the iconic Golden Gate, uses massive main cables draped between two tall towers. From these main cables, vertical suspender ropes hang down to hold up the bridge deck. This design allows for incredibly long central spans, making it ideal for crossing wide bodies of water or vast, open chasms. The forces are elegantly transferred from the deck up the suspenders to the main cables and then down into the earth through the massive anchorages at either end. The cable-stayed bridge, on the other hand, offers a different kind of grace and efficiency. In this design, numerous smaller cables stretch directly from the towers to the bridge deck below fan-like pattern, harp-like pattern. Each cable is a discrete element supporting a specific section of the roadway. This method is exceptionally efficient for medium to long spans and has become a signature of modern Chinese bridge engineering. The forest of taut cables creates a visually stunning aesthetic, a testament to the precise balance of tension and compression that holds the entire structure aloft, seemingly with effortless elegance. Choosing between these designs is a complex decision for engineers. It depends on the specific geology of the location, the length of the span, required the expected traffic load, and the environmental forces at play, wind, seismic activity. In China's diverse landscape, both designs have been pushed to their absolute limits. Engineers are not just building bridges, they are creating bespoke solutions for some of the most challenging crossing points on the planet. Each new structure is a carefully calculated response to a unique geographical problem, a testament to the sophisticated art of spanning the uncrossable. While colossal bridges and high-altitude railways command our attention, some of the greatest engineering is never seen at all. It lies hidden deep beneath the earth in a vast, unseen world of tunnels and subterranean networks. These are the silent arteries of the modern landscape, critical components that make much of the visible infrastructure possible. In a country where mountains cover over 2/3 of the landmass, burrowing through them is often the only logical solution. Tunnels allow for direct, all-weather routes immune to the snow-ice landslides, providing a level of reliability that surface roads can never match. These underground corridors are essential for creating an efficient, high-speed transportation system. For a high-speed train to maintain its velocity, it requires a route that is as straight and level as possible. In a mountainous country, this is only achievable by alternating between bridges that leap across valleys, tunnels that pierce straight through the mountainsides. This combination creates a land bridge, a smooth and seamless pathway that ignores the chaotic topography of the surface. As a result, China has become the world's most prolific tunnel builder, with a total length of tunnels that could stretch halfway around the globe, a testament to the scale of this subterranean ambition. The challenge of tunneling goes beyond mere transportation. In many of China's densely populated urban areas, there is simply no more space on the surface. To accommodate growing populations and alleviate crippling traffic congestion, cities have had to expand downwards. This has led to the construction of vast, multi-layered underground systems that contain subway lines, highways, shopping centers, pedestrian walkways. This subterranean world is a complex, three-dimensional city hidden beneath the visible one, a sophisticated solution to the pressures of modern urban life, keeping the metropolis moving and functioning efficiently. From controlling floodwaters to protecting critical infrastructure from seismic shocks, this hidden engineering is fundamental to the nation's resilience. Massive underground reservoirs can store excess rainwater to prevent urban flooding. Utility lines for water-powered data are increasingly buried to shield them from natural disasters and to free up space on the surface. This invisible infrastructure is the unsung hero of the modern nation, a silent and robust network that ensures the stability and connectivity of the world above. Some of the greatest engineering is, indeed, never seen. As China's cities have grown at an unprecedented rate, they have expanded outwards, upwards, and also downwards. The result is the emergence of a parallel subterranean city, a complex and layered world of infrastructure. It forms the hidden bedrock of urban life. At the heart of this world is the metro system. Cities like Shanghai, Beijing, Chongqing have built massive subway networks in a remarkably short period. These systems are the lifeblood of the megacity, moving millions every day with an efficiency impossible on crowded streets above. Building these tunnels presents unique challenges. Excavating beneath a bustling city means navigating a dense web of building foundations, utility pipes, historical structures. Work must be surgical to avoid subsidence or surface damage. Engineers use earth pressure balanced TBMs that manage pressure at the cutter face to match surrounding soil. keeping the ground stable and the city undisturbed. It's a delicate, high-stakes operation, performed just meters beneath millions of feet. The subterranean city is more than transport. It is integrated for human activity. Subway stations connect to underground shopping malls, food courts, climate-controlled pedestrian networks, letting people walk kilometers without surfacing. This creates comfortable, convenient urban space, shielded from summer heat, winter cold, heavy rain. Spaces are designed with bright lighting, clear signage, efficient ventilation to feel open and welcoming, transforming underground areas into vibrant, essential urban fabric. Downward expansion is also a strategy for resilience. Placing critical infrastructure underground protects cities from natural disasters. Underground power grids are safe from typhoons. Subterranean reservoirs capture and manage stormwater to prevent flooding. The sponge city concept uses underground space to absorb and reuse water, turning a hazard into a resource. Engineering the subterranean city is a forward-thinking urban planning approach, building more efficient, livable, and sustainable megacities for the future. The relationship between China's engineering and its environment is not one of outright conquest, but rather a complex and ongoing negotiation with nature's immense power. It is an unstable alliance. Innovation must constantly adapt to a landscape prone to violent, unpredictable events. This is most evident in the country's active earthquake zones, where the very ground is a source of peril. Engineering has moved beyond simple strength to embrace resilience. Structures are designed not to rigidly resist an earthquake's force, but to intelligently absorb and dissipate energy, allowing them to bend and flex without catastrophic failure. This philosophy is embedded in the DNA of modern Chinese construction. This has produced sophisticated earthquake-resistant structures: skyscrapers, Chengdu; skyscrapers, Kunming. CGI Cutaway, a skyscraper showing a massive tuned mass damper pendulum near the top, swinging in opposition to the building's sway during a simulated earthquake. Bridges on colossal isolation bearings that let the deck move independently from the shaking ground. Entire residential communities are now built to strict seismic codes, reinforced foundations, and flexible superstructures. This is engineering born from a history of tragedy. The battle against water presents another front. Flood-prone regions along the Yangtze River Basin. Flood-prone regions along the Yellow River Basin. The focus is not just on higher levees, but on integrated systems that can handle massive influxes of water. Mega dams regulating river flow and capturing floodwaters. Vast water diversion projects channeling excess water from the flood-prone south to the arid north. South to north water diversion project, continental scale. In the deserts of the north and west, the challenge is stabilization against encroaching sand. Building railways across shifting dunes. Building highways across shifting dunes. A technique known as straw checkerboard barriers is used, where a grid of straw is manually pressed into the sand. The grid stabilizes the surface and allows drought-resistant vegetation to take root. This creates a living, self-sustaining barrier that protects the infrastructure. Earthquakes, floods, deserts. In each of these cases, the engineering is a direct problem-solving response. A testament to innovation under constant pressure from the natural world. The human foundation, hands, minds, and sacrifice. Behind every colossal bridge, every high-altitude railway, every gleaming skyscraper, there is an often overlooked foundation: the human element. The story of China's engineering transformation is not just one of steel, concrete, and advanced machinery. It is fundamentally a human story. It is a narrative written by the hands and minds of millions of people, from the visionary chief engineers who spend years designing a project, to the construction workers who toil in dangerous conditions to bring that vision to life. Every structure begins with human hands and human risk, with personal dedication and immense collective effort. The true unseen pillars. The architects and engineers are the masterminds, solving immense puzzles posed by nature and physics. They work for years, sometimes decades, on a single project, running countless simulations, testing materials, and refining designs to ensure safety and efficiency. They are responsible for every calculation, every blueprint, and every decision that will determine whether a structure stands for a century or fails under pressure. Their work blends scientific rigor and creative problem-solving, a relentless pursuit of perfection where margins for error are non-existent. But the designs on paper are meaningless without the army of workers who translate them into reality. This workforce, numbering in the millions, is the engine of construction. They are the welders, the crane operators, the concrete pourers, and the tunnel drillers. They often come from rural parts of the country, leaving homes and families for months or even years to live in temporary dormitories on remote construction sites. Their work is physically demanding, repetitive, and frequently dangerous. They endure extreme weather, from the biting cold of the high plateau to the searing heat of summer, working long hours to meet tight deadlines. This journey is one of profound personal sacrifice. Parents missing their children's formative years, individuals risking their health and safety for the promise of a better future for their families. The immense speed of China's development has been built upon the backs of this generation of migrant workers. Their contribution, while often anonymous, is the lifeblood of these projects. To understand the true scale, look beyond the finished product and see the human cost and craft embedded within every weld, every rivet, and every cubic meter of concrete. More than monuments, infrastructure as possibility. As the sun sets and the lights of the megacity begin to glow, as a train disappears silently into a tunnel, a new perspective emerges. These colossal structures, which dominate the landscape and defy the imagination, are not intended as monuments to power or to the state. Their true purpose is more profound and more personal. They are monuments to possibility. Each bridge, tunnel, and railway line is a physical manifestation of a collective belief that the future can be better, more connected, and more prosperous than the past. They represent a fundamental investment in the potential of people and places that were once held back by the constraints of geography. This infrastructure is the framework upon which new lives are built. For a student from a remote mountain village, a high-speed train is not just a mode of transport. It is a pathway to a world-class university and a future of expanded opportunities. For a farmer in a distant province, a new highway is not just a road. It is a direct link to urban markets, a means of turning hard work into economic security. For a family separated by a wide river, a bridge is not just a structure of steel. It is the promise of more frequent reunions, the weaving back together of the social fabric. These connections are the real, tangible outcomes of these engineering feats. Over time, these once extraordinary feats of engineering blend into the fabric of the ordinary. A bridge that was a global news story during its construction becomes a simple, unremarkable part of a daily commute. A tunnel that required years of perilous work becomes a mere 2-minute passage in darkness on a train journey. This integration into everyday life is perhaps the greatest measure of their success. They cease to be objects of awe and instead become reliable, invisible enablers of modern life, their function so seamless that they are taken for granted. They are the silent, steadfast architecture of a new reality. In this light, the immense scale and ambition of these projects can be understood not as an end in itself, but as a means to an end. The goal is not merely to build the highest bridge or the longest tunnel, but to create a nation where distance is no longer a barrier to progress, where opportunity is more evenly distributed, and where the potential of every citizen can be unlocked. These structures are, ultimately, a bet on the future. They are a declaration, written in concrete and steel across the face of the land, that with enough ingenuity, effort, and vision, a better connected world is not just a dream, but a tangible, engineered possibility. Thanks for watching. Make sure you subscribe to our channel for more exciting videos.